All right, we're going to prove that this sum here is equal to this sum, and both of these sums are equal to 2 to the n minus 1. So let's start with the proof. So in previous videos, I showed that n choose 0 plus n choose 1 plus n choose 2 plus dot 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 all the way to n choose n is equal to 2 to the n. And I showed that n choose 0 minus n choose 1 plus n choose 2 minus dot dot dot, and then plus negative 1 to the n choose n was equal to 0. So we're going to use these two in order to showcase this equality here. Okay, so the first thing I'm going to do is I'm going to let e equal this sum here. So that's n choose 0 plus n choose 2 plus n choose 4 plus dot dot dot, right? And I'm going to let r be equal to this sum here. So that's n choose 1 plus n choose 3 plus n choose 5 plus dot dot dot. Okay, so now looking at this, right? Let's look at e plus r, right? So e plus r is n choose 0, right? N choose 0 plus n choose 1 plus n choose 2 plus n choose 3 all the way to n choose n, right? So e plus r is this right here. This first equality we have here is 2 to the n, right? And let's look at e minus r. So e minus r, right? So that's n choose 0 minus n choose 1 plus n choose 2 minus n choose 3 all the way, right? So e minus r, right, we can see is this equality right here. So we know that's equal to 0. So now let's go ahead and look at, well, right, let's look at e plus r plus e minus r, right? So e plus r is 2 to the n, and e minus r is 0, right? So e plus e is 2e, r minus r is 0, so we know 2e is equal to 2 to the n, because 2 to the n plus 0 is 2 to the n. And then, of course, if we divide both sides by 2, I get e is equal to 2 to the n minus 1. So I've shown, right? So I've shown that n choose 0 plus n choose 2 plus n choose 4 plus dot 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 is equal to 2 to the n minus 1. So I've essentially gotten half of what I want, right? So now I need to try to get this guy here. Okay, well, instead of looking at e plus r plus e minus r, let's look at e plus r minus e minus r. E plus r is still 2 to the n, and e minus r is still 0, right? Okay. Well, e minus e is 0, and r minus negative r is 2r. And of course, 2 to the n minus 0 is 2 to the n. And then this gives me r is equal to 2 to the n minus 1. So I got that n choose 1 plus n choose 3 plus n choose 5 plus dot 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 was equal to 2 to the n minus 1. And look at what I have. I have this sum here, right? So I have, therefore, I have, let me scoot down a little bit, n choose 0 plus n choose 2 plus n choose 4 plus dot 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 is equal to, it's equal to 2 to the n minus 1, which is also equal to this series here, right? Like this sum, which is equal to n choose 1 plus n choose 3 plus n choose 5 plus dot dot dot. And both of these sums are equal to 2 to the n minus 1. And that is what we set out to do. That is our proof.